Okay, good morning, everybody. Thanks for joining us. A little bit late. We were waiting for some registrants to sign in this morning. A few people were a little bit late. We really appreciate you coming out and taking interest in probabilistic analysis with the use of Monte Carlo simulation as a technique. So my name is Andrew Sitch. I'm the Regional Sales Manager for Palisade Corporation. I've been with the company for a little over 7 years, and this is one of my most favorite things to do is to show off the software because it's really great stuff that helps our customers make more informed decisions. So today's presentation objectives are going to be initially just to introduce you to Palisade Corporation as a software partner. Then we're going to spend a few minutes demystifying Monte Carlo simulation and understanding why it matters. In fact, I'll be showing it kind of on a theoretical level and then taking you into a model for the basics. And then we're going to bridge into a very interesting model. It's like a telecommunications model. And we're going to be talking about the 4 basic or fundamental building blocks to be able to do probabilistic analysis with your Microsoft project files. We've actually got quite a bit to cover, so I'm going to be flying through a lot of this presentation. The PowerPoint portion will be hopefully less than 10 minutes. We'll spend the bulk of our time within Microsoft Project and Excel to show you the building blocks, how to generate charts and graphs as a result of the Monte Carlo simulation, and there's some really interesting advanced features I want to show off to you first. We have any time at the end. We'll get into some of our free online instructional resources to help support the use of the tool. So let's begin. Palisade Corporation, we're considered to be the market leader of Monte Carlo simulation as an add-in to Microsoft Excel. And At-Risk is our flagship product within the Decision Tool Suite. I'm not going to be touching on any of the other products today aside from At-Risk. If you're really curious, please go to our website and you can explore all the tools. They're all for decision-making in the end. So Palisade Corporation, we have our humble headquarters in Ithaca, New York, but we're an international company. We now have offices in London, Sydney, Rio, Cuenca, that's in Ecuador, and most recently we opened up an office in Tokyo. And in parallel with that, the software is available now in 8 different languages. So Monte Carlo simulation as a technique for probabilistic analysis is really what's driving our growth. One of the things we like to boast about is our core development staff has been together for a long time. And this is important to our customers because the best way to describe it is to give an example. When Microsoft came out with Excel 2007 and Microsoft Project 2007, there were leaps beyond Excel 2003. And our developers had to be fast on the heels of Microsoft when they came out because a lot of our customers like to be on the cutting edge of this kind of technology. And we needed to be there for them when they made that jump. And having that core development staff together is key to that. They're also extremely responsive to our customers when they come up with new ideas to improve the software. And if they happen to find any bugs, they're quick to take a look at those and fix them in subsequent releases. Palisade Corporation is a certified Microsoft partner. We get the beta licenses from Microsoft for Excel and Microsoft Project so we can continue to improve our software. We're also an Intel software partner. We're recognized by a handful of professional organizations for teaching their members in the use of At-Risk for their scheduled risk analysis. In fact, you can earn PDUs through PMI as we're members there. The software is also used and taught at the majority of colleges and universities in North America and Europe, and that's expanding rapidly into the Pacific Rim and South America as well. Today, we estimate we have about 150,000 analysts who use At-Risk actively, and that is at every level of government, all across all military disciplines, every higher education level that you could imagine, across all industries and business sizes, and that includes 93% of the Fortune 500 companies use our software today. So this is why we're here, schedule risk analysis using Monte Carlo simulation. The old way of risk modeling is the use of single point estimates. The natural progression from there are to use 3-point estimates, worst case, best case, most likely scenarios. And then the natural progression from there, yet again, is to do manual what-if analysis. In other words, taking some number or some task or some cost, for example, and changing it so it's somewhere in between, for example, worst case and most likely place. But that's a very time-consuming and error-laden type of approach, especially when you're considering projects with thousands or tens of thousands of tasks, and having those tasks move at different times and in different directions and in different amounts is very, very difficult to capture. And this is what the software does. It allows you to capture that movement that happens in very complex projects. So the new way of risk modeling is the use of probability distributions to understand how a project may behave. And the probability distributions are the direct result of Monte Carlo simulations. And so what probability distributions do is they furnish you and the decision makers and stakeholders with a full range of possible outcomes, how likely those outcomes are to occur, and it identifies the main drivers that impact the project's schedule and cost. So what is Monte Carlo simulation? It's really not rocket science. It's a fairly simple concept. Essentially what you do is you run thousands of scenarios of a project. It's like an experiment before you actually launch the project. And in that repetition, you generate lots of data. And what the software allows you to do is easily collect that data, organize the data in such a way that it's easier to analyze and communicate to stakeholders, and allow a fuller understanding of associated risks. So let's use here's where the theory comes in. We're going to use a very common or simple example. We're going to roll some dice, and I'm going to have you pretend that you don't know how dice behave. So when we're setting up the model, the first thing we have to do is we have to define the parameters of rolling dice, and there's really just two. The first one is that we have 2 dice, and the second one is each die has 6 possible outcomes. So again, imagine you don't know how the dice behave. We're going to do a virtual experiment and roll those dice 48 times and collect the result, and this is what you get, a bunch of numbers. So this looks chaotic to me, and I need to make order out of it. Right now, I don't see any kind of pattern. I've collected the data, but I need to take it a step further. So one thing that I can do is I can condense those numbers so that I'm just looking at the totals. So there's fewer things to look at. And now, for some of us who may be able to discern a pattern, I still don't see a pattern. I still need more help. And so the next step after collecting the totals is to organize the figure in such a way where some picture begins to form so we can understand the behavior of dice. And this is essentially where we get our ubiquitous histogram, a picture that begins to draw, allow us to understand what's going on. In this case, you can see snake eyes and double sixes are the outliers. Lucky number 7 is in the middle. With just 48 rolls of the dice, you don't get a very nice, smooth, curved kind of jaggedy, but it still illustrates something very important. So that's Monte Carlo simulation in a nutshell. And as a review, all we're doing is we're running a virtual experiment that repeats a project or a rolling of the dice a large number of times and generates a large number of randomized data that we can collect, organize, and analyze. So the benefits of using at risk, because we're going to get into some modeling very, very shortly, is that it's easy to use. You're already working in an environment that you're familiar with. Microsoft Project and Microsoft Excel. All at-risk functions are true Excel functions, and you'll see the integration with Microsoft Project and how they play together shortly. Peace of mind. We've been around for a long time. We have many customers who like to prod and poke at our software, come up with new innovative ways of using it, and we take that input very, very seriously, and the result is very stable, highly regarded software. And perhaps most importantly, one of the benefits of using at risk is it's very easy after the simulation, Monte Carlo simulation is run, to be able to communicate how complex systems behave so that it can inform the decision-making process. So aside from at-risk, I already mentioned we have the decision tool suite, but we have a full support system behind at-risk. We have professional training classes, we have consultants, we have custom development work, developer kits and books, all to help support the use of the tool. And this is on top of the free resources that we have online that hopefully we'll have some time to show. Okay, enough of the PowerPoint presentation, let's get into a model. Okay, so this is the model we're going to be working with first and foremost, and then we're going to bridge into an actual project. And this is just to reinforce what we talked about with the dice. So in this case, we have two dice, die 1 and die 2, and here's their total. And one thing that I do with at-risk is I color my cells that have at-risk inputs and outputs to help guide my eye. So whenever you see a yellow shaded cell, it has an at-risk input or distribution. Anything pink has an at-risk output. And you can color your cells using this menu item here in at-risk. So let's do a visual examination of this distribution, and then we'll build this distribution from scratch. And to do a visual examination, we'll click on Define Distributions, and this is what we get. The distribution is showing us that we have 6 possible outcomes, which makes sense for a die. And this is the frequency area, and it's telling us that each number has the same likelihood of occurrence. The same is true here. So 2 die that aren't loaded. So let's delete this one. And in a blank cell, what we'll do is we'll go back up to the Define Distribution, but this time what we get is our palette of possible distributions. We have many to choose from, 79 in fact, at this stage. Most of our customers only use 2 or 3, so please don't be overwhelmed by this. These are sometimes industry-specific types of distributions. So the first thing we're going to work with is a discrete distribution. Anything in red is considered to be a discrete distribution. Anything in blue is a continuous distribution. So for a die, I know I can't roll a 2.5 or a 3 3/4. I can only do a 1, 2, 3, 4, 5, or 6. And again, with a blank cell, this is the default that we get. It's essentially an 11-sided die, which we don't want, but we can modify that very easily in this control portion of the window. So I'm going to double-click in the min window and change that to 1, because our die begins with 1. I'm going to change the max number to 6. And now we have a distribution for our die. You click OK, and now that's added into your cell. And here's the output. The output, or the forecast cell, is typically what we assign an at-risk output to. And in this case, what we're looking at is the sum of cells A3 and B3. So what I'm going to do is I'm going to remove this at-risk function and show you how easy it is to add an at-risk output. You simply click on Add Output. At-risk is what the output, the title should be. You click OK, and you're done. So I'm going to do a virtual die roll 5,000 times, run an experiment 5,000 times to help us understand the die roll using the software. So let's begin that process. So here we go. In demo mode, the numbers are changing very rapidly. All those numbers are being collected, and the output graph is being formed before our eyes. So this is kind of slow because it's in demo mode. It's robbing my resources of a lot of my PC of a lot of resources. So what I'm going to do is I'm going to speed this up by turning off the visual recalculation. You can see it speeds up quite a bit more. And this is what we get. Now we have 2 die, and here we have snake eyes and boxcars, double 6s, as the outlier, which makes sense, and lucky number 7 in the middle. So what I'm going to do next is I'm going to throw a monkey wrench into our die model. And I'm going to do this because life is not symmetrical. So with the 3rd die, recall we have 2 normal dies here, and the 3rd die is abnormal. You can see the function window is showing something pretty strange. So let's do a visual examination. Again, I'm going to click on Define Distributions, and what it shows us is a die that has a virtual hunk of lead on the virtual 6 side. So when I do a virtual roll of that die, the 6 will is the least frequent number to show up. It's most often facing the table, whereas the 1 is most often up in the air and visible. And this cell right here, we're simply taking the sum of cell C3 and the sum of the funny die and adding them in here. And we can go ahead, I'm going to reduce this a little bit to 1,000, and we're going to simulate 2 normal die and 1 loaded die and see what the behavior is there. Okay. So even in a very simple model, very quickly, we can understand that it may be difficult for us in our minds to grasp what the effect is of a strange die or a loaded die when combined with 2 normal die. But the simulation runs very quickly. Now we can say, oh, look, this kind of makes sense. 18, 17 are very, very rare. And here are where most of the results come up in these 3 numbers. This would be 9 through 11. So 28% of the time, we're going to get 9, 10, or 11. So that's one way to interpret things. Okay. Again, we've got a lot of stuff to cover. I know you may have some questions. Feel free to get a hold of me. Write down your questions if you'd like these answered in more detail, because we have a lot to cover. So we're going to get out of here, and we're going to open up a project. So note, if you can see my tray right here, I don't have Microsoft Project open. But it will open automatically when I go to the project menu item in At Risk, and I import an MPP file. I think I have one on my desk. I guess I have to have an open file. There we go. So I'm going to open up this one right here. So note that there's nothing in the Excel spreadsheet. We're going to open up this MPP file, just a very basic MPP file. And what's going to happen is At Risk is going to, again, open the file and then import all the data into Excel. I can open this up a little bit further and this a little bit further. And so this Excel version of the Gantt chart is the same as what we see here. So what At Risk did is it opened this file, this MPP file, and imported all the information into Excel. We're not going to do our At Risk work in the MPP file. We're only going to do it in the Excel file. During a simulation, what happens is the random numbers are drawn in Excel. They're then sent to the MPP file. The MPP file calculates the changes of those random numbers that were drawn, and then they're returned back to the Excel file for reporting purposes. So what I'm going to do now is I'm going to engage these 2 little guys so you can see what happens. This is a step-by-step iteration of a project. So for example, this is one scenario or one path that the project may take. Let me shorten this here, and then also bring up the MPP file. So you can see what happens. So when I tap on the F9 key, you can see that the numbers, you get a new number in here. It's sent over to the MPP file, which calculates a result. So they're now talking to one another. They're mapped perfectly. So you can see, let me open this up just a little bit further. 241.61 days matches here. This has 11.21 days as it does over here. And if we go through another iteration, you'll see that the changes are mimicking one another. Okay, so that's what happens when you first import a project into Excel with At Risk. Everything's mapped over. Okay, so next what I'm going to do is we're going to go to, this is not the model that I actually want to show you. I just wanted to show you how the import process works. The one that I want to show you is a little bit different, and it has a lot of interesting advanced features in it. Let's see, I'm I'm going to go here and open up this one, Risk Register and Advanced Modeling. All right. So one of the things I did with this model is I actually turned off the Gantt chart portion. So for example, here's its respective MPP file, and the Gantt chart is intact. And I've turned it off here, so I'm going to show you how to turn that on or off. So you just go to Charts and Reports and Standard Gantt, and then I can say Display the Gantt chart in Excel. Click on OK, and those bars are in there. I found those distracting, so I'm going to turn that off, just so we can concentrate on the columns. Okay, great. So the first thing I want to do is I want to do a visual examination of a task that has a distribution in it. In this case, we're looking at data handling for the TR12 system. Actually, let me make this a little bit bigger. Okay, so right now we're showing the expected value of 205.333 days, and we're going to do a visual examination of that distribution. Click on Define Distribution, and this is what it looks like using a PERT distribution. You can see we're using cell references in this case rather than numbers. So I can change this. I can, if I wanted to go in here and say, well, the minimum should really be 10 instead of what may be in D26, and I'll show you that in a second. And it changes the distribution a little bit right before your eyes, and then you can click on OK, and it's added in there. So now I want to show you how to do add distributions in several different ways. So for example, you could go into a blank cell and you can add a distribution to it. So I'm going to go to Define Distributions, and remember, in a blank cell, it opens up our full palette of distributions. Here are our most common. So I'm going to use a PERT distribution in this case, and we have triangular and trigen and the uniform and just about anything you really want. So I'm going to stick with the PERT distribution, and I'm going to say, oh, you know what, this may take as little as 10 days. More likely it's going to take 100, and the high may be 156 or something like that. And it automatically draws my distribution. And all I have to do is click on OK, and that distribution is now added here. Now I'm going to show you how to do it with cell referencing. So I'm going to actually delete all of these to show you how easy it is to do. Okay, so we're going to start here. We're going to define distributions. We're going to choose PERT. And we could just simply type in the cell reference here, but we have an easier way to do it. First, what you want to do is click this little button here, and my cell references are down here. So for data handling, the low is 0, the most likely is 220, and the high is 352. Now those cell references are added to my box. I click on that button again, and my distribution is now built. I click OK. And now what I'm going to do is I'm going to grab the cell and draw all the way down. And you can see that the cell references as I go through the cells are kept intact. Yep. Okay. So that's one additional way. You can add a distribution manually, just typing in the parameters, or you can do cell references. Oftentimes, what our customers do is they build the model or have subject matter experts fill in forms. So this you could imagine as some kind of a form given to some subject matter experts, and they put in their numbers. And what's also interesting with cell references is if one of the subject matter experts says, oh, I made a mistake on the uplinks, this should really be 25 as a low. I don't have to go back into my distribution to change it. I can just change it right here because we're using cell references. So if I go to uplinks, you'll see I'm still using cell references, and you'll see that my low number will have changed from 0 to 25 when I click on Define Distributions. There we go. 25, and you can actually see the minimum here is 25 too. Okay, so we have a couple of other ways that you can enter the distributions. Before I do that, I'm going to do a best practice here, and that is to clear my at-risk data. I often run many simulations, and it fills my cache file with lots and lots of data, and I need to, every once in a while, empty that cache file so that things run smoothly. And you simply do that by clicking on Simulation Results and OK. And just as repetition, you'd go to Utilities, Clear At-Risk Data, and then Simulation Results. Okay, so let's see here. Okay, so let's do risk categories. So let's say that you have a set of risks that may be considered high-risk categories, and they have the same kind of distribution associated with them. So when you go up to the project menu item, go to Model Tools and click on Risk Categories. And so what I'm going to do is I'm going to create a new risk category called High Risk. And I'm going to set the parameters. I'm going to use a triangular distribution. I can change it to a PERT if I like, but we'll stick with the triangular for demonstration purposes. And then I'm going to set the maximum at 50%. So there'll be a number. In this case, I'm going to put it on Project Design Review and Critical Design Review, where it's going to vary from 2 days by 5% downwards and 50% upwards. I'm not quite done. I have to actually add those. So I go here, and I select these two items, click OK, and they're now added to my category list of high-risk items. I'm going to click OK. At risk overwrites what's in there, and you can see here the risk vary function has been in there, added in there. And it's called a high-risk function. And you can see when I turn on the two die and tap on F9, how the numbers change. Another way of adding distributions in a quick manner, and again, I understand many of you work with projects that may be hundreds, if not tens of thousands of tasks long, and so this can be an arduous task. So we have another way to make this move a little bit faster. Under Project, I'm going to go to Model Tools again, but this time Parameter Entry Table. And we're going to go to Duration. We're going to be working with duration. Again, we're going to choose a triangular distribution, and we're just going to do something basic, like maybe, we'll keep 10% there and maybe have it increase by 20% on the high side, and we're going to include all tasks. We can also choose selected tasks and just click through which ones we want, but let's do all of them so you can see what happens. When I click OK, there'll be 3 columns added. Duration min, duration most likely, and duration max, right here. And all the numbers are plugged in based on the percentiles that I designated in the risk parameter entry table. And when I go back to my distributions, you can see here that we're using those cell references. So it doesn't matter which cell I go into, I can see that we're drawing off of cell references. And again, if we engage the die, now all of them are done the same way. So you may want to start out your entry of your distributions this way and then go into adjust. You can send this particular worksheet to subject matter experts and have them fill in the duration, min, max, and most likely numbers, and it feeds directly into the distributions for the, in this case, the duration. You can, of course, set it to the finish date as well. Okay, so now I've showed you a handful of ways to enter distributions to specific tasks. The next thing is we want to add an at-risk output to a couple of places. Already we have an at-risk output associated with the cost here and this finish date. I don't even know why somebody put that in there, but I really wanted to have an at-risk output on the project summary level. And to do that, again, just click on Add Output. At-risk understands what the title should be. I also want one on the finish date, so I'm going to click on Add Output. And you can see the risk output function has been added to these 2 items. So now we're ready to simulate, to understand what the distributions, what kind of effect they have on the bottom line. Let me see here for 1 second. Okay, let's run a simulation. We'll do a quick one. Actually, before I do that, I want to make sure that things move somewhat quickly. So I'm going to change the project settings to make sure that they don't calculate these statistics. And that's just for now. We're going to go ahead and iterate, do 100 experiments or iterations of this particular project. And the first one we're going to be looking at is the finish date. So during the simulation, what's happening is these random numbers that are being drawn by at risk are sent over to the MPP file, which calculates the changes in Microsoft Project and then returns the results to Excel for collection and reporting purposes. And so this is the result of our work now. We're looking at the finish date ranging between the minimum of 3/27/2012 to the most furthest date of 4/12/2013. And so there's a 90% chance, and this is the one way you can begin interpreting the results of the Monte Carlo simulation. So there's a 90% chance that this particular project will conclude between 4/27/2012 and 2/7/2013. I can also look at the duration rather than the date. So if I want to speak in terms of duration, then I can say, well, there's a 9% chance that we're going to be between 615 days and 819 days until this project concludes. You can also grab these delimiters and move things over. So maybe you initially had some thought that maybe this is going to have to finish within 650 days. So you can move the delimiter over there. And the way to interpret this is to say, you would say there's a 22% chance that the duration of this total project is going to take 650 days or less. And the flip side of that is there's a 73 plus 5% chance or 78% chance that it's going to take 650 days or more. So if you're looking at the P95 value or the P90 value, depending on which side you really like to look at, this shows you the P95 value, that 95% of the time this project will finish 819 days and a half or less. Or I can go to the, actually I'll do it this way, you can just type in the number and the delimiter moves for you. P90 number is 787.8 days or less. There's a 90% chance it'll happen, 10% chance it'll be 787 or above. Sometimes we like to focus the attention of the stakeholders a little bit more. So maybe the original thought was that this particular project was going to take 675 days. So I'm going to click on this little button right here, and what it does is it brings up our graphing options dialog. And this is my favorite, the markers tab, because it helps focus the eye. So I'm going to click on mean, and then I'm going to click on x of 1, and I'm going to redefine x of 1 to be my target finish. In this case, we want to be, we'll call it target finish duration. And we'll call it 675 days. Click OK, click OK, and now those markers are added to my graph. And now we can say, we can drag this delimiter over, and we can talk in probabilities and ranges of likelihood. So now there's a 36% chance that we're going to be below that date, but we maybe have to reconsider this project in a number of different ways, because 59% of the time, sorry, 64% of the time, we're going to be beyond 675 days. And so one of the questions may be, why? Why are we going, why is the probability of exceeding the duration above 675 days at 64%? Why don't we have a better likelihood that it's going to be less than that? With Monte Carlo simulation, we've collected a lot of data, and now it's at our fingertips. So I'm going to click on this little button right here. It provides us a sensitivity analysis. We have 5 different types to choose from. I personally like this one best. I find it easiest to interpret. So I'm going to click here, and it provides us a tornado diagram. And the values are expressed as coefficients. Coefficients will always go between -1 and +1. The closer it is to -1, the greater the negative impact on the outcome is. In this case, a negative impact is a good thing because it's reducing the time, the duration of the project. The closer it gets to a positive one, the greater the positive impact it is on the total duration. With a project, it's probably not the best thing to do to add more time. But what the tornado diagram does, or the sensitivity analysis does for us, is it helps us identify which items are impacting the bottom line the most. What's causing the duration to go so far? So very quickly I can see that these two items have the greatest impact on the bottom line. In fact, I can grab this bar and drag it out, and I can take a closer look at it. And so what the scatter plot tells me, this is interesting. We have a lot of numbers in here. Probably want to take a closer look at this distribution to see what's going on. But essentially, what this is telling us, we'll read the percentiles in the quadrants based on the positioning of the delimiters. So remember, we wanted to be at 675 days. And let's take a look at this, this risk being at 50 days right here. So what this is telling us is the chances of coming in under 675 days when the risk impact is 50 or less days is 36%. There's a 36% chance that we'll be below 675 days for the total duration of the project, and that this particular risk will be under 50. So another way to interpret it is we can go to another quadrant and say if the schedule, Tower 1 risk schedule impact exceeds 50 days, the chances of going above or beyond 675 days total duration is 37%. So we can see what's going on in here a little bit closer. Okay. Sometimes our customers like to look at these distributions not as histograms, but instead as cumulative ascending curves. So this right now is the duration. Sometimes with the duration, probability density is a little bit better, but when it comes to finish date, sometimes we want to look at this as a cumulative ascending curve. So you have that option just by clicking on this little button right here, and cumulative ascending curve. In fact, you can have, there's a way to overlay these. So you have both the histogram and the cumulative ascending curve. So one of the questions that people often say was like, okay, this is fine and dandy, I'm seeing you're playing with this, but I need to report this to somebody. I need to send it to somebody. And the nice thing about at risk is you can right-click in here, copy the graph. I'm going to pull in my PowerPoint. So there's my PowerPoint, and I'm going to paste it into my PowerPoint. You can do the same thing and drop your results into a Word document, an email, anything you want, just with a couple of clicks. So it's very easy to share with stakeholders and other people. Okay. Okay, so we got about 20 minutes. I have to speed things up a little bit. I'm going to go back to project and change the project settings to calculate critical indices and these other things. And you'll see that the simulation takes a little bit longer. But I want to do that for you so you can see some of the other reports. Whoops, that's not what I wanted. I wanted to start simulation. Okay, so here's our distribution. And what we're going to do now is go to Project, Charts and Graphs, and look at the probabilistic Gantt chart. And so we get this report. And so this gives us a probabilistic Gantt chart, not just with the blue lines, but with pink lines. So these lines represent means, and the distance. This is like the 95th percentile, this particular red bar. This is the 5th percentile. If you look at some of the others, you can see here's the 5th percentile. So in other words, this portion of the Gantt chart is showing us this is what the deterministic was, but with a probabilistic distribution, it can go far beyond based on how the other tasks may be affecting it, as well as the distribution that was assigned to this particular model. So you can see this has a huge impact. This particular task is hugely impacted either by the distribution, but more likely by what the predecessor tasks are doing to it. So there's another way to study what's going on. And this is also interesting. What this tells us is the amount of time that a particular task stays on the critical path. Because it varies, it may not always stay there, or it may pop into the critical path. So right now, this one, this right here is 79% of the time it's on a critical path. We have some others that are not on a critical path at all, and some others that have some significant impact on the critical path. So again, this report, just like all the others, provides you with more information to drill down and make changes in your project to help meet certain project goals, or to scrap the whole thing entirely, or to communicate what the difficulties are. All right. Oh, sorry, I deleted the wrong one. All right, so what I want to do next is I want to show you the risk register. So one of the things that's difficult to do with Microsoft Project is to assign the effect of risk events on your project. So here I have a risk register tab. So when I look in here, what we have, I'm going to take you through this logically. What we have are risk events and what they're called. Here's the probability of these risks occurring. Here's the probability of it not occurring. And this is expressed as a distribution in this cell right here. So let's take a look at that. So the probability of this event not occurring, which is 0, is 60%. It's right here. The probability that it would occur, which is a 1, is 40%, which is right here. And so here it's a little bit different, 80% chance that it won't occur, 20% chance that it will occur. It's a little bit backwards. This is the probability that it will occur. This is the probability that it won't occur. And this is just some cell formatting. Like when a 1 pops up here, this will turn red and will have the word yes in it. So when I pop on the dice, we can go through one iteration and you can see this event occurred, and so it's a yes. It's just a fancy way to provide a visual. Now, when an event occurs, it has an impact on some task or set of tasks. And we can also assign a distribution to what that impact is. And that's what this portion of the risk register shows. So if an event occurs, the minimum effect is 15 days. The most likely effect is 100 days. And the maximum effect is 200 days. This is the mean effect. And this is expressed using a risk-PERT distribution, drawing off of these cells right here. And again, we can do a visual examination. There's a risk-PERT distribution with a minimum 15 or a maximum of 200 days, and you can see that also in the statistics tab here. And if an event occurs, those many days are added to the plan. We can also, the same logic applies for cost. So if you're dealing with cost too, I'm going to talk a little bit about integrating cost with schedule. Use the same logic here. If an event occurs, you can have this cost added to the plan and also assign a date to have it happen. And here is where we map back to the task. So if an event occurs, we have to somehow map this back to some task. And so that's expressed here. And so if you look at this, we're using a special risk function called risk project add delay, and we're going to be adding the 91 days for this particular instance to the tasks tab in cell B8. So let's go to cell B8 in the tasks tab. Cell B8 is right here. And if you look at that, that's simply text. And you would wonder, well, how does one add 91 days to text? This is actually where the cell maps back to Microsoft Project. So I want to show you how that works. When I run a distribution, and actually I want to do this one. I'm sorry, when I run a simulation, I'm going to bring up this as well. You'll see that the tasks here in the MPP file match the tasks here in the Excel file. So what I'm going to do now, which I didn't describe to you before, is I'm going to run the simulation and show you what happens, how we map the risk events to the MPP file. Start that simulation. Actually, let me pause this. Make it small. Maybe I stopped it. Let's do it one more time. Okay. So here we are. We're running through the iterations. I'm going really fast. I'm going to have to do 500 iterations. Hold on a second. It's going too fast. Close. Help. Utilities. Okay. I'm going to change this to 500. Start the simulation. Okay, so the simulation has started. Now let's go over to the Task tab. The Microsoft Project, it's not letting me do it. Let me pause it for just a moment. Oh, I was pressing the wrong button. I apologize for that. So anyway, I've paused this in the middle of it, but you can now see that the risk events that we had named in the Risk Register tab have now been added to the MPP file. So I'm going to restart this. And this is not working to show you what's going on. So let me stop this again for a moment. I apologize. And let's go here. That should do it. Okay. Now you can see every once in a while when these risk events occur, you'll see a little blue bar appear here when the risk event occurs. And it's connected to its predecessor task. So when an event occurs, that number of days, for example, you saw that 91 days were added in that one instance. That's added to its predecessor task. So let's see if I can pause this at the right moment. Nope. Let's try again. There we go. So here we had an event that happened. I'm not sure which one that is. Let's take a look. So that was the TR12 ground system INT risk. And it was just a minuscule little event. The event happened, but it was just a minuscule duration that was added, and it was sent back to this task up here. It looks like it's a critical design review. So we can continue running this, and you'll see that as the simulation is occurring, the probability of these risk events is also now being included in the project, and we're capturing that data. So let's speed this up a little bit. Actually, I can stop it at this point. When we go to the tornado graph, we go back to the Risk Register tab. We'll go back to the names. Here are the names that we're looking at. And there are the results. So these are the risk events that happen that are impacting the duration and or the finish date too. So very quickly, I'm going to review that one more time because there's actually quite a bit of information there. The Risk Register tab And developing a risk register is relatively simple. Just follow the steps of, number one, naming your risks, identifying them, having a subject matter expert perhaps identify how likely the risk is to occur or not. If you get that, if and when you get that information, you can define the distribution as a discrete distribution. The event either happens, which is 1, or it doesn't, which is 0. So let me show you how that happens. Define distribution. I want a discrete distribution. I want to change this to, actually, I'll get rid of this one. 1. So the chance of this one happening is 40%. Chances of it not happening is 60%. So I change the table editor to reflect what my percentages are here. I can also use cell referencing. You click OK, and it's done. The next step after you define the distribution for the probability of an event occurring is to define what the impact is and which task or tasks it impacts. And again, we can use a min, most likely, and max to apply a certain number of days to a particular task or set of tasks. And if an event occurs, we can say there's 42 days added for this one particular path that the project may take. And then we tie that back to a particular task. In this case, it's the task in the Task tab under cell B8. Again, this sometimes takes a little, when I show this to customers, I usually have to show it 3 or 4 different times, only because we're combining Microsoft Project with that risk, with Excel, and to show how to build a risk register in Excel may take a few moments. So anyway, that's how you do that. If you have any questions, of course, again, you can contact me. So another thing I wanted to show you, though, is now how to integrate cost with project and to understand the interplay. So in this case, we've already built the costs in here. We've got some costs with distributions. For example, this one has a risk triangular distribution right here. We can do that to any cost. We can resource load and then roll it up. And here's the entire cost of this particular project. So when we review the cost, we can say, well, how does that compare to the duration? This button right here allows us to compare. So I'm going to click here. Now we need to choose the cell to compare to cost. In this case, I'm going to choose duration. Let's double check here. Oh, I'm sorry. I have to add an output there. When I closed down this particular file, I forgot to add the output, the at-risk output, so I just have to rerun that simulation. I'll just do it 100 times. Okay, good. Now we have the cost and the duration. I can start with the duration too, and then add the cost. Whoops, I clicked on the wrong button. I apologize. So let's browse results for the duration, go back to the scatter plot button, and now select cost. Click OK. What we get is a scatter plot. And remember our quadrants. And this is how to interpret this. So this y-axis right here, it's telling us about the entire duration of this project. And this one is telling us about the entire cost of the project. So remember, we were looking at 675 days that we were targeting as the duration, ideal duration for completing this project. And maybe we were eyeballing at $4 million as a total cost that was budgeted for this. And this is very, very telling. So the probability of coming in on time or before, or on budget or under, is 24%. And then, of course, the opposite, the probability of coming in beyond the 675 target duration and above the $4 million number is 34%. So it provides us with a lot of very interesting information. And again, you can use a sensitivity analysis or a tornado diagram to drill down to figure out where are we falling down and perhaps where we should place our resources to improve our odds of finishing on a finish date that is good for us, or within a duration that works for us, or our stakeholders are demanding, and within budget. Okay, we have just a couple more minutes. So I had one other model that I wanted to show you that actually ties it's a mining example model that ties the length of preparing a mine for ore extraction to financials. Like, what is the NPV of being able to, or what is the NPV or distribution of the NPV based on the duration of a project of mine? I apologize, I just don't have the time to get into that now. If you're really curious about how to tie project schedule risk to financials, send me an email or give me a call. We can schedule that at a different day. So what I want to do next is I want to take you into our website. So you just go to palisade.com. And there's a number of different things that help support the use of the tool. The first thing I want to show you are the free online video tutorials. To reach those, go to Training and Events and hover over Videos, and then go, and then go to Guided Tours. So when I click on Guided Tours, you want to choose At Risk, and it opens up, it starts the video process. And what we have, you can see the video already starting, and it's going to be working with a ribbon overview, but you have an index of video tutorials, one for each feature in the software. So for the project-centric videos, you need to scroll down to near the bottom of that item here, and then simply click on Project. And that starts the videos, video tutorials for project. And this will review many of the same items that I reviewed during our time together here. So there's somebody actually talking there. It's not just somebody moving around with their mouse and with no instruction. There's actually a professor there who will be talking when you start this video. Okay, so back to the main web page. Under Customers, you also find case studies. So I'm going to go to by industry, and you can go to, for example, government and defense. And so we have a number of different case studies under the government and defense heading. The first one that comes up is At-Risk Help Set Budgets for Social Services, but we also have all of these. For example, UK Ministry of Defense and Project Management. And so there's dozens and dozens of case studies that our customers have worked with us to develop to show how the tools help them inform the decision-making process and manage the risk. So again, under Customers, you can go to Case Studies and either sort by industry or product. Also, under Training and Events, when we go back here, you can go to Free Webcasts. So when I click on Free Webcasts, we come up to our free live webcast. Here's our schedule. That's me today. You'll see not only my colleagues at Palisade Corporation doing some of these, but you'll also see some of our customers in the live webcast schedule. And then in the webcast archive, you're also welcome to access these if you like. For example, there's a really great one for project. It's called Mega Project Cost and Schedule Estimates. So I just click on, or do a Control F and type in NASA, and then all you have to do is click on View Now, and for 68 minutes you can listen to Glenn Butts talking about using at-risk for project planning purposes. And we have dozens and dozens of webcasts that you can access on a very wide variety of topics and subjects. We also have white papers. I think it's under Company, News, and White Papers. And again, they're organized in a certain way. So for example, government defense. And so these particular white papers go into great detail about the project that they're working with and the use of our software. The other item I wanted to point you to, this may be the most important one, on the main web page, we have an annual risk conference that we hold. It's in Las Vegas this year, and it's on November 20th and 21st. And the number of people that attend this is roughly between 150 to 200, and it's a it's a 2-day-long 5-track conference. So when you click on schedule, you can see the tracks. The first track are software presentations done by Palisade trainers and developers. So if you need to know more specifically about the use of the tool, like what button to press to do what thing, or the capabilities, these are the items you want to, the sessions you want to attend. The other blue sessions are case studies done by our customers. So we have CH2M Hill, we have people from universities, we've got some large engineering firms, CH2M Hill, for example, Premier Blue Cross. I believe we've got Lockheed Martin in here. So you can see a nice wide array of uses of the tool across a number of different industries. The fifth track is not here. It's actually a custom expert session. So if you want to attend and you have some specific questions about your particular model or how to use at risk, all you have to do is ask us to set up a session. I think they're 30 to 45 minutes. You can bring in your laptop, your model, and ask as many questions as you like of our consultants. So again, at-risk conference, don't miss it. It's our 8th annual. It's a lot of fun. We build a lot of time in, to get to know not only the other registrants that are joining you, but also time to ask questions of the presenters. We have nice lunch and after-hours events to do the same. It's really a lot of fun. People love to talk about their work, so there's a lot of passion in what's going on, and we hope that you can join us as well. And to register, just click on the nice blue button. So that concludes my presentation for the day. I know it's a lot of information. You probably have many questions. I encourage you to send me an email or call me. In fact, let me bring up my information again. There it is. So again, I'm Andrew. There's my email address, asitch@palisade.com, and that's our toll-free number. My direct extension is 330. So I hope to hear back from you. I hope you found the discussion of the demo lively. And again, feel free to reach out with any kind of questions you may have. Thanks again, and have a great day.